Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 13 in linked list series. So far I covered 12 lectures and I highly recommend you to please start watching from lecture 1 so that you will be able to understand all the variants of problems which we are solving in this series. And without further delay, let's get into today's lecture. In this video, we are going to solve one more lit code problem. The difficulty is medium and problem number 82. This is a different variant of lecture 12. So where we solved remove duplicates from sorted list. So I recommend you to please look at that video, then come to this so that you can able to understand it this easily. So in this problem, we need to remove all the duplicate elements and we need to return only the distinct elements. Let's try to understand this in a diagram. If we have a list something like this, 1, 2, 3, 3, 4, 4, and 5. Here we can see 3 is duplicated one and 4 also. We need to remove this completely. Okay, then we need to return only the unique element, that is 1, 2, and 5. 5 next is null. So this is how our output should look like. Let's see how we can solve this problem. If my list is something like this, 1, 2, 3, 3, 4, 4, 5, 5 next is null. What I am going to do here is I am going to create a dummy node here, and dummy node dot next is going to be the head. Why I'm taking this? Because this is going to help us to solve this problem and that you can able to understand while we are going to solve this problem. And if you're not aware of this dummy node concept, in previous lectures, I already used this concept and where I explain the significance of this one. I highly recommend you to please watch my previous lectures also. Now what I'm going to do here is, so I'm going to take a previous pointer which is going to point to the dummy node. So the purpose of this pointer is to hold only the unique nodes. Okay. And my head is at this position. So every time what I'm going to do here is my head and its next are equal? No, they are not equal. Then what I'm going to do, I'm going to move my head by one position and my previous pointer by one position. Next, is my head and its next are equal? No. Then I'm going to move my head one position, then my previous one position. Now here is the case. Please pay attention. Is my head and its next is equal? Yes. Then I'm going to move only my head, not the previous. And is my head and its next is null? I mean equal? No. Then what I'm going to do here is my previous dot next is going to be the head dot next and head is going to be at this position. Okay, and I'm not changing the pointer here. Just I'm saying previous dot next is equals to head dot next. Then is my head and its next are equal? Yes. Then my head is going to point here. Is my head and its next are equal? No. Then my previous dot next is going to be head dot next. That is nothing but here. And my head is going to be here. And is my head and its next are equal? Its next is null. And we are end of the list. And if we carefully observe, my output is like this. Minus 1, 2, and 5 null. Then I'm going to return dummy node dot next so that it can able to return 1, 2, 5, and null. That's all. So what are the time and space complexities? The time complexity is going to be big of n because we are iterating through the nodes only once. And the space complexity is going to be big of 1 because we are not taking any additional list or a data structure. If you are unable to understand this problem, please do let me know in the comment section. I will be very happy to explain you in detail also. Let's get into the coding part. And here is I am. The base condition is if head equal to null or head dot next equal to null. That means we need to return the head. Otherwise, I'm just creating one dummy node dummy node is equal to new list node of minus 101. I can tell you why I am taking minus, because the node values ranges from minus 100 to plus 100. So I would like to take the value which is out of the boundary. And then dummy node dot next is going to be our head. Then I'm going to take one prev node which is going to point initially to the dummy node. And now let's start. So the condition is while head not equal to null. Till this condition satisfies, what we need to do? If head dot next is not equal to null, in this case, what we are going to do? If head dot val is equal to head dot next dot val, in this case, then what I'm going to do? I'm going to check while head dot next not equal to null and head dot val equal to head dot next dot val. Till this condition satisfies, what I'm saying, just move your head to one position forward. Head is equals to head dot next. So when this condition becomes false, then what I said, prev node dot next is equals to head dot next. That's it. And if this condition is not satisfying, okay, then what I need to do in else in else prev node is equal to head dot next, and at the end just do head is equals to head dot next. And once you complete this, just try to return the dummy node dot next. Dummy node dot next. Yeah, that's all. Let's try to run it. Expected output 1 to, okay, 3 needs to be skipped. So maybe in else case wrong. So if my head val and its next is not equal, so what we need to do here, if you carefully observe, if they both are not equal, then my prev node is equals to prev node dot next is equals to head, then prev node is equals to prev node dot next, then head is equals to head dot next. That is anyhow we are doing here. Then prev node dot next is going to be head dot next, I mean head prev node is equals to prev node dot next. Let's give a run. Yeah, let's submit it. Yeah, it got submitted successfully. So that's all for this video. I hope you learned something new today. Please do subscribe to my channel if you're liking my content. Thanks a lot. Bye bye.